Okay, Algebra 2. This is the biggest test you're going to have short of the final on this semester. Covers all things quadratic, our biggest unit. So we're covering everything on units 5 and 6. So everything on unit 5 and 6. So that goes from 5.1 to this is 6.10. So everything in there will be fair game. So we started out with complex numbers. How do I add complex numbers? Combine the real parts and then the imaginary parts. So this just becomes 7 plus 3i, okay? All of these answers for complex numbers need to look like this: a plus bi, real number plus imaginary number, okay? I to the 51st power. Remember, the whole purpose here was, let's figure out what happens when you divide 54 by 1. That remainder is going to be I to that power is my answer, okay? So because I to the 4th is 1. So I'm grouping these as 1s. 4 goes into 51. It would go into there, what, 1 time. That leaves you 4. 4 goes into 11 2 times. That leaves you 3. So my remainder is 3. So I to the 51 is going to be the same as I cubed, which is my remainder. And remember, I cubed, if you don't remember that one, remember the way we did that. That is I squared times I. You have to remember that I squared is negative 1. So I cubed is going to be negative 1 times I. That's just negative I. So that is my answer there. If the remainder had been 2, then this answer is I squared. If the remainder had been 1, the answer is I. The remainder is 0, that's I to the 0 or 1. 1 over 3 minus I. Okay, dividing by a complex number. Remember, this was just an exercise of knowing that you need to multiply by the 1 in the form of the complex conjugate over the complex conjugate. So you have to multiply this by 3 plus I over 3 plus I. On the top, I get 3 plus I. On the bottom, I FOIL this and I get 9 minus 3I plus 3I minus I squared. Okay, and then I just got to combine things. The nice thing about that is by design, those two middle terms go away. So this is 3 plus I over 9 minus, what did we say I squared was? That's negative 1. So this becomes 3 plus I over 10. To write it in the form a plus bi, this is 3/10 plus I over 10. Okay, that is my final answer there. Multiplying two complex numbers. It's just like doing binomials. You multiply the first two terms together and you get 2. Multiply the outside terms together, you get minus I. Inside terms plus 2I. The last terms minus I squared. So this gives me 2 plus I minus negative 1. So this is 2 plus I plus 1. This answer is 3 plus I. Graphing. This is something we did a while. You've got to bring this all back. Okay, there were 3 different forms we graphed in. This specific form is vertex form. Okay, so graphing in vertex form. You know the formula, or you should know it. Y is equal to x minus h squared plus k. The vertex is hk. The axis of symmetry is x equal h. It is not h, it is x equal h, okay? The direction of this thing opening, this direction, this guy opens down because there is a negative in front of this. What is the vertex? The vertex is a negative 3, 4, and the axis of symmetry is x equal negative 3, okay? So if I graph these, negative 3, 4 is this point right here. The axis of symmetry is this. This thing opens down. I just need a couple of test points to tell me what is happening. So I'm going to pick a couple of points. If this is at negative 3, let's see what happens If that's -3, let's see what happens at -2. At -2, when I plug a -2 into this function, I'm going to get negative, it's going to be what, 1 squared plus 4, that's 4 minus 1, that's 3. So -2, 3, I get this point, which means I also have a matching point there. I can pick one other point just to be sure what's going on. Let's try at 0. If I plug in a 0, then I get what, 4 minus 9, that's -5. So I get this point right here. So 1, 2, 3, 1, 2, 3. So right there. So I know that this parabola does this. Okay. And I did not ask it, but this point right here, that is called the y-intercept. Okay. That is at 0, -5. Provide the requested information and graph this one. This guy is in intercept form. Remember that form was y equal a, x minus p, x minus q. It had the axis of symmetry is the line x equal p plus q over 2. It has x-intercepts at p0 and q0. Okay, so the direction of opening, this guy opens up. The x-intercepts are at -3, 0, and 1, 0. Remember, this formula has a minus built into it. So if you think about it, this is 2 times x minus -3, x minus 1. Okay, so those intercepts are -3 and +1. The axis of symmetry is going to be x equal -3 plus 1 over 2, which is -2 over 2. So x equal -1. So at -1, that's my axis of symmetry. I know that this guy goes through -3, 0, 1, 2, 3, and 1, 0. So it goes through those 2 points. It opens up, so my parabola had better be, excuse me, did I do this right? Hold on. Yeah, minor mistake here. The symmetry looked off. 1, 2, 3, it's right there. Okay, so now I'm good. So the vertex had better be in the middle. So to find the vertex, I know that the x-coordinate of the vertex is -1. So I need to plug -1 into that equation. So go back to my original equation. If x is equal to -1, I get y is equal to 2. -1 plus 3 times -1 -1 minus 1. So this is what, 2 times 2 times -2, which is -8. So the vertex is a point. The vertex is -1, -8. Okay, that's the way you write the vertex. The vertex is not -8. It's -1, -8. So right here is the vertex. Okay, and so I should be able to graph this guy. If I wanted to get an extra point, I could plug in 0 and get the y-intercept. The y-intercept is going to be at -6. So I'm going to see that right here. That just gives me a little bit more accuracy. And there I see this parabola doing this. Okay. What is the domain? Every parabola that we've done has a domain of -∞ to infinity. The range, the first y value I see is at -8. So -8 to infinity is the range. Okay, now I see a couple things. I see standard form and I see an inequality. So I got to handle that. Okay, so this is in standard form. Standard form, y equal to ax squared plus bx plus c. The axis of symmetry is x equal -b over 2a. The y-intercept is the point 0, c. And I know that when I draw this thing, this is going to have a dotted curve because it says greater than, not greater than equal to. So this thing, this opens upward. The axis of symmetry is x equal negative of negative 8, that's negative b, over 2 times a, that is 8 over 4. So x equal 2 is the axis of symmetry. Okay. The vertex, okay, all I need to find the vertex is to plug it into that equation. So I know that x equal 2, so 2 times 2 squared minus 8 times 2 plus 3, that is 8 minus 16 plus 3, that is what, negative 8 plus 3, which is negative 5. So 2, negative 5 is the vertex, so which is right here, okay. And I know that the y-intercept is going to be 0, 3. So is that right? So if I get that as my y-intercept, I also have this point that is matching right here. Okay, so I should have enough to graph this guy. So when I go and graph this, remember it's going to be a dotted curve. Something like this. And then I just need to figure out where do I shade. So I need to test it. I'm going to test this equation with the point 0, 0. So 0 greater than, what is it? It's going to be 0 minus 0 plus 3. Is 0 greater than 3? The answer is no. So that means that 0, 0 is not part of the solution. So when I shade the solution region, it doesn't include 0, 0. So it would be this area that you see right here. Solve by any method. Okay, the key here is, be on top of all the different methods and to be very solid about how these apply. So in this guy, I see something squared. So this looks like, well, actually, I think it's a typo. I think it was meant to be. Well, let's just do it like it is, and then we'll do it like I think it was meant to be. I think there was supposed to be a 7x there. So the way it's written, you could just say this is x squared, minus 51 equals 0, x squared equal 51, take the square root of both sides, x is plus or minus the square root of 51. And let's see, does that simplify any further? I don't think so, because that is 3 goes into there, 2, one time, once it's 3 times 17, so it doesn't simplify. That would be the answer. What I think this problem was meant to be was this, minus 7x minus 44 equals 0. On a test, don't interpret what I meant, just do what was written. So this would factor if I could find two numbers that multiply to negative 44 and add to negative 7, okay? It looks like 11 and 4, and if the 11 were negative, then that would do it for me. So that means that because this thing starts with a 1 in front of that x squared, this represents my factorization. X minus 11 times x plus 4 equals 0. Therefore, x is equal to 11 or negative 4. Okay. The next one. Okay, so let's look and see about this. I prefer to factor if it can factor first. You could just go straight to quadratic formula, it doesn't matter. Let's see if I can factor it. Are there two numbers that multiply to negative 20 and add to negative 8? So what are the factors of 20? 1 and 20, 2 and 10, 4 and 5, 5 and 4, then I start repeating. Is there any way to combine these numbers and get a negative 8? It looks like if I had a positive 2 and a negative 10, those numbers multiply to negative 20 and add to negative 8. So I can rewrite this as 4x squared plus 2x minus 10x minus 5 equals 0. What can I factor out of those first two guys? It looks like I can factor out a 2x, and I'm left with 2x plus 1. Copy down the sign that you see next, which is a minus sign. What do I see in common with the next thing? It looks like a 5. What do you multiply negative 5 by to get negative 10x? That is 2x. What do you multiply negative 5 by to get negative 5? That's plus 1. So this tells me 2x minus 5, 2x plus 1 equals 0. Set each of those equal to 0, and you will get x is equal to 5 halves, or x is negative 1 half, okay? Alternately, the way you could have done this, you could use the quadratic formula, okay? So if you use the quadratic formula, a is equal to 4, b is equal to negative 8, c is negative 5, and you should be able to get to the same answer there. The next one, this one is the path of least resistance is square roots, okay? You've got something squared, okay? Take the square root of both sides. X plus 1 is plus or minus the square root of 14. X equal negative 1 plus or minus the square root of 14. You're done. There's no simplifying for square root of 14. Look at the next one, same thing. I see something squared that I can isolate. X squared equals 128 over 2. That means x squared is equal to 64. Take the square root of both sides. Plus or minus the square root of 64. X equal plus or minus 8. Quadratic formula would be overkill on these two problems, okay? Now here's the next one. You got to be sure we only solve these things set equal to 0. So before you do anything, get to here, okay? Set this thing equal to 0. I like to first see, does it factor? Are there two numbers that multiply to 3 and add to 2? These are the only possibilities. There's no way to add those numbers and get a 2. This does not factor. I'm going to have to use quadratic formula. A is 1, B is 2, C is 3. So B squared minus 4AC is going to be 2 squared minus 4 times 1 times 3. That is going to be 4 minus 12 equal negative 8. So that's B squared minus 4AC. My solution is going to be X equal negative B plus or minus the square root of B squared minus 4AC over 2A. So this is X equal negative 2 plus or minus the square root of negative 8. That's going to be I times the square root of 8 over 2. I can write this as negative 2 plus or minus I, the square root of 2 times 4 over 2. So X equal negative 2 plus or minus I times 2 times the square root of 2, all of that over 2. A lot of 2's there that I can simplify. So this is X equal negative 2 over 2 plus 2I over 2 times the square root of 2. That's a plus or minus. So this simplifies to X equal negative 1 plus or minus I square root of 2. Next problem. So this guy, it will factor if I can find two numbers that multiply to 4 and add to 4, okay? That's not going to work, okay? Or wait, I think it will work, sorry. Two numbers that multiply to 4 and add to 4. So 2 and 2 will do that for me. So I can write this as 4x squared plus 2x plus 2x plus 1 equals 0. Factor out a 2x, 2x plus 1 plus 2x plus 1 equals 0. So this is 2x plus 1 times 2x plus 1 equals 0. Set those equal to 0, you get x equal minus 1 half, okay? If you had used quadratic formula, it works out almost just as quickly. So x equal negative b plus or minus the square root of b squared minus 4ac over 2a. So you get x equal negative 4 plus or minus the square root of 0 over 8. So this is x equal negative 1/2. So either way, got to the same answer there. Convert to standard form, okay? I want this to look like y equal ax squared plus bx plus c. The only way to do that is to multiply out everything you see. So y is equal to 2, x plus 2, x plus 2 plus 3. Y is equal to 2. When I FOIL this, I get x squared plus 2x plus 2x plus 4 plus 3. Y equal 2. X squared plus 4x plus 4 plus 3. So this is y equals 2x squared plus 8x plus 8 plus 3. Final answer. Y equal 2x squared plus 8x plus 11. Okay. Convert to standard form. Again, the only way to do this is just to multiply out what you see. Y is equal to negative 3. When I multiply this, I get x squared plus x minus 2x minus 2. Y is equal to negative 3. X squared minus x minus 2. Y is equal to negative 3x squared plus 3x plus 6. Convert to another form. Convert to intercept form, okay? To convert to intercept form, remember intercept form is y equal a, x minus p, x minus q. That means get it into factored form. That's begging you to factor this guy, okay? So y is equal to, so I need two numbers that multiply to negative 28 and add to 3. Okay, the factors of 28, I can write them all down here, and 4 times 7. The only way I can get a 3 out of that is to have a negative 4 and a positive 7. Okay, so that tells me I can write this guy as y equal x minus 4, x plus 7. Okay, and that is in intercept form. Convert to vertex form. Okay, this is the one that's a little bit more involved. Okay, converting to vertex form, we have a couple ways of doing this. Okay, so the first way of doing it is I can find the vertex. Okay, by looking at the axis of symmetry. So if you look at this, this is y equal a x squared plus bx plus c. So I know that a is equal to negative 1. B is equal to negative 6, C is equal to negative 10, okay? The axis of symmetry is x equal negative b over 2a, which is negative of negative 6 over 2 times negative 1, which is negative 3. So if I know that's the axis of symmetry, I know that the vertex is found by plugging that value in. So when x is equal to negative 3, I get negative of negative 3 squared minus 6 times negative 3 minus 10. So this is negative 9 plus 18 minus 10. So this is negative 1. So I know that the vertex is negative 3, negative 1. Okay, if I know the vertex, then I can get this in vertex form. Okay, I know A and I know the vertex. So this is y equal negative, okay, and then it's x plus 3 squared minus 1. Okay, that gives me the vertex of this guy. Now the other way, let's see if I can find a little space here, is the other way to go to vertex form is to do completing the square. So if I've got y is equal to negative x squared minus 6x minus 10. Well, I can write this as y equal negative x squared plus 6x, okay? Factor out that negative 1 to begin with, okay? And then figure out, okay, how am I going to get to complete the square here? So I need to be able to add, what, 3 squared, okay? So I'm going to add 3 squared. So what it looks like I'm doing is I'm subtracting, in here, when I'm adding 3 squared with that negative, it's really what I'm doing. I'm subtracting 9. If I'm going to subtract 9, the only way to offset that is to also add 9. So this becomes y equal negative, and this is what, x plus 3 squared minus 1, which is the same equation. Now we come to where we're finding the equation of quadratics, okay? So if I look at this, find the equation, the thing that sticks out to me is, what am I given here? So I'm given places where the y value is 0. Those are x-intercepts. So I've got 2 x-intercepts at negative 11, 0, and 7, 0. Well, that is telling me, if you know x-intercepts, let's go to intercept form. So y is equal to a, x plus 11, x minus 7. That's what this parabola has to look like, okay? But I know the other point is, if I plug in a 0, I should get 154 back. So this has to be true. 154 is equal to a, 0 plus 11, 0 minus 7. So 154 is equal to a times negative 77. And if I divide both sides by negative 77, I get a is equal to negative 2. So this final equation is y equal negative 2, x plus 11, x minus 7, okay? Find the quadratic passing through this vertex and through the point negative 3. So since they give me a vertex, that is telling me that this is the form that I want to go with, okay? So y is equal to a, x plus 3 squared plus 1. So all I don't know now is that leading coefficient, but I do know if you plug in a negative 2, you had better get a 3 for y. So 3 has to equal a, negative 2 plus 3 squared plus 1. 3 is equal to, this is going to be a plus 1. So a is equal to 2 in this case. So this parabola is y equal 2, x plus 3 squared plus 1. And now the next one gives me 3 points. And the important thing is none of those points are x-intercepts. And I'm not told that any of those points is the vertex. So the way I'm going to need to handle that is with my TI Inspire. So I'm going to have to create a list and spreadsheet. So I'm going to have some x values and I'm going to have some y values. And so let's figure out what they are. The x values are 1 and 3 and 4. And the y values are 1, 4, and 7. Okay, so those are my points. Just go back to a calculator page and menu, statistics, stat calculations, quadratic regression. This is a quadratic. My x values were that x, and my y values were y. And what do we come up with? So there they give us, it's a is equal to 0.5, b is negative 0.5, and c is 1. So this equation is ax squared plus bx plus c, so it's 0.5 squared minus 0.5x plus 1. So this is y equal, what did I say? Look at that again, 0.5, so it's 0.5x minus 0.5, so it's 0.5x squared minus 0.5x plus 1, or you could write it as 1/2 x squared minus 1/2 x plus 1, okay? So that is the equation. Let me double check that. That was a is 1/2, b is negative 1/2, and c is 1, okay? So the key there was I didn't have any intercepts to figure that out, okay? Let's look at the next guy. Consider this function. This parabola opens down. This is in standard form. What is the axis of symmetry? That's x equal negative b over 2 times a. So this is going to be 8. Excuse me, no, it's 4. So that's going to be negative 16 over negative 4, which is 4. So x equal 4 is the axis of symmetry. And where is the vertex on this guy? So the vertex, what happens when you plug in a 4? So you get negative 2 times 4 squared plus 16 times 4 minus 30. So this is negative 32 plus 64 minus 30. So this is what, 32 minus 30, which is 2. So my vertex is 4, 2. Okay. And let's just figure out what else we need. They ask us to find the x-intercepts. Okay, so let's look at all the stuff. The x-intercepts. So to find the x-intercepts, let me look at this real quick. Remember, to find the x-intercepts, I'm going to need to set this guy equal to 0 and then solve that quadratic. So let's look at that down here. So to find the x-intercepts, remember you've got y is equal to negative 2x squared plus 16x minus 30. Okay, so what I need to do is to set that equal to 0. So let's do that. Negative 2x squared plus 16x minus 30 equals 0. I can factor out a negative 2, and I get x squared minus 8x plus 15 equals 0. Okay. Now, what has to be set equal to 0 if this is only going to be 0 when what is in parentheses equal to 0, because the negative 2 will never equal 0. So when does x squared minus 8x plus 15 equal 0? That will happen if I can find two numbers that multiply to 15 and add to negative 8. So it looks like a negative 3 and a negative 5. Those numbers will multiply to 15 and add to negative 8. So this is x minus 3. X minus 5 equals 0. Therefore, x is equal to 3 or 5. Now, what did they ask me? What are the x-intercepts? The x-intercepts are points 3, 0, and 5, 0. Those are the x-intercepts. Okay, so the x-intercepts are 1, 2, 3, 0, and 5, 0. Okay, if I need to find an extra point, let's pick, say, x equal to 2. Okay, so just something near the vertex. If x were equal to 2, I haven't subbed that one in yet. When x is equal to 2, this gives me negative 8 plus 32. 32 minus 8 is 24. 24 minus 30 is negative 6. So when x is equal to 2, I get -6, which is right down here. So, which means I get this point right here. So I should be good enough to graph this guy now. What is the domain of this function? -infinity to infinity. What's the range? -infinity all the way up to 2. Okay. Rationalizing. How do I rationalize this? This first one needs to be multiplied by the square root of 5 over the square root of 5. This gives me 7 square root of 5 over the square root of 5 times the square root of 5. So that's 7 square root of 5 over 5. The next one, this needs to be multiplied by the irrational conjugate. So 1 plus the square root of 2 over 1 plus the square root of 2. So this becomes 2 plus 2 square root of 2 over, when I multiply the next ones, multiply here, I get 1 minus the square root of 2 plus the square root of 2 minus the square root of 2 times the square root of 2, which is 2. This cancels. So I get 2 plus 2 root 2 over -1. So that's -2. So that's -2. -2 minus 2 root 2. And then we'll see a couple more things here. Complete the following. What's the value of the discriminant? So b squared minus 4ac. That's going to be 2 squared minus 4 times 1 times 2. So that's going to be 4 minus 8, which is -4. The discriminant is negative. I get 2 complex solutions. Looking at the next one, the value of the discriminant here is b squared minus 4ac. That's 2 squared minus 4ac. So that is 4 and plus 24, which is 28. Okay, that's real, that's positive, it's not a perfect square. I'm going to get 2 real irrational roots for that guy. Give the equation of this parabola. This is a parabola that has 2 x-intercepts at what, -4, 0 and 2, 0, and it passes through the point -1, -3. So I'm going to use intercept form. Y equal a, x plus 4, x minus 2, okay? And because that passes through what, -4, +2. I know that when you plug in a -1 for x, you get a -3 back for y. So -3 is equal to a, -1 plus 4, -1 minus 2. -3 equal a, 3 times -3. So -3 equal -9a. So a is equal to -3 over -9, which is 1/3. So this equation is y equal 1/3 x plus 4, x minus 2.